Good morning, everyone. Myself, Ashu Sharma, Assistant Professor, CSC Department, Arya Institute of Engineering Technology and Management, Jaipur. Today, we will see image compression, and in this, we have subtopics variable length coding, run length coding, and LZW compression. So, let's start with that. Okay. So variable length coding, as its name suggests us that variable is something which is going to be changed. As its name suggests also that coding, we represent some symbols through that coding stuff. So variable length coding is a part of that in which different symbols represented by variable length of coding, variable length of binary bits, or it is some that encoding techniques. So it is that lossless compression technique. So there is no loss in the information. Maps source symbols to a variable length code. So source symbol that is mapped with variable length code, and it allows source symbols to compress and decompress with zero error. So compression and decompression happens with zero error. It is lossless compression technique. Now this is that example we have. Initially we have this input that given table symbol and code. These are the symbols A, B, C, D, E, F, G, H, and this is that given code with respect to each symbol. So as per this start point that we may opt any sequence of bits as per the given table information. So here we have this given input sequence. Now encode this by using any of this sequence from this input table. So first we prefer that AAA, that sequence is coming like this 0 0 0, because input table we have A equals to 0. Then we have BB, so B is also 1 1. Then we pick this C, that double zero, and then AAA, so 3 times 0 0 0. Now for variable length code, we may take any of that sequence, but that should be mapped with this input table information. So here we take these three zeros and map it to G, capital G. Then we take two ones, then map it towards capital F. Then again we take these three zeros, map it to G, and then two zeros and map it to C. So this way that variable length code is completed. Now uncode this concept again with variable length code, which is different that of with the previous one. So now we take two zeros, which is C. Then we take one zero, which is A. Then we have two ones, again F, it maps to F. Then two zeros, it maps to C. Then two zeros, it maps to C, and then one zero, it maps to A. So how we take these sequence, it is arbitrary and it depends on us. But one thing should be remembered: whatever the that pairing we are taking, that should be mapped with the input table. So that is one thing that we should consider when we will apply this technique. Now next is again we take now in variable length 3 that 1A for zeros, two zeros for C, then 1 1, two different ones for B, and 0 0 0, 3 times 0 is for G, and finally two zeros is for C. So this is that we have for this variable length coding now. Now from this, how to uncode that concept. So we have this uncode one, which we have taken, and then this is the variable length. And when we have to encode, just simply put this A equals to 0. So three zeros are there. Then BV, two ones are there. Then C, two zeros are there. And then three A's, 0 0 0 is there. So this is the way that during the compression and decompression technique, we don't see any error. So this technique is very, very vital, which is lossless compression technique. And because of we have different variable length of code for each symbols, that's why this technique is known as variable length coding. Now the next type is run length encoding. Here we have, again, this is a lossless compression technique. Same data value occurs in many consecutive places and stored as a single data value and count. So run length encoding is also a technique which is lossless compression technique. Now see this example. This is the input sequence. We have 5 times zeros, then in follow up with 5 times ones, then two zeros, 1, 4 zeros, 1, 0, 1. So we count these number of zeros. This is 5, so 0, comma 5. Then this is 1 5 times 1, comma 5. Then 0, 0, 0, comma 2. Then 1, comma 1. Then 4 zeros, 0, comma 4. Then 1 once, 1, comma 1. Then 0, 0, comma 1. And 1, 1, comma 1. So this is the way we just count how many that pairs we have. Start from 1, 2, 3, 4, 5, 6, 7, 8. Now take this as 0 and make it 5 in the binary. So 5 in binary becomes 101, and same way we complete this whole number of pairs. Now what we see that log base to 8, total count is 8. So we will apply this formula log 2n and 8. With the help of log properties, it becomes 2 cube and 3 log 2. So log 2 over base 2 is equals to 1, and it becomes 3 bits. So 3 bits representation that we use for this representation of symbol coding. Now we just make sure that all these given pairs that should be combined. So start with this 0 1 0 1, 0 1 0 1 up to this, then 1, this one, and then finally 1 0 1, then this two zeros and 1 0, and finally in this way we complete the final code. So this is the way that run length encoding appears and works. Now the next technique is LZW compression. LZW is a universal lossless data compression algorithm. Again, it is a lossless data compression algorithm and abbreviated as Lemper-Welch. LZW is the compression of a file into a smaller file using a table-based lookup algorithm invented by Abraham Lemper, Jacob Schiff, and Terry Welch. On the name of these scientists, researchers, that name is given to the algorithm. It is a process of reducing size by encoding its information more efficiently. So somewhere compression takes place, and because of that lossless data, so again we don't lose any information while applying this compression technique as stuff. A smaller file size is generated in order to achieve a faster transmission of electronic files and a smaller space required for its downloading. Now it replaces a string of characters with single quote. Now LGW compression technique commonly used file formats which is TIFF, tagged image file format, GIF, graphic interchange format, and PDF, portable document format, and Unix compress and gzip. It is also suitable for some compression text files. Compression occurs when a single code is output instead of a string characters. The first 256 codes are by default assigned to the standard character set, and a new string of characters is added every time it sees to a table of strings. So these are the different file formats that use this type of technique. Now see this example. Initially we have this dictionary, index and entry, two columns are there with 1, 2, 3 and A, B, C assigned to this. Now this is the input sequence, and this is the encoded output that we have to evaluate. Now firstly we will enter in this table, we make another table and enter these values into this table. 1 2 3 A B C. There is no encoded output till this point. Now we start with scanning with this. A is already in the table, then we take AB. So AB is not in the table, so we assign index C and take that value from the index of just previous to that foremost one. So we take this one, A. A having index 1, so put 1 over here. Now we take BA. B is already there, so we have to take BA, this one. BA is not a symbol that was in the entry. So BA we take, index assigned to 5, and B having this index value 2. So we put 2 over here. Then we have AA already there, AB is already there, ABB. ABB is not there, so we take this 6 here. And AB having index value 4, so we put 4 over here. Then we have BA, BA is already done, BAB. So BAB is this, that index value is 7. And BA having that index is initially that 5. Once we completed there, so put 5 over here. Then AB is already that complete. BC, BC is not there, so BC will be take and take index over here 8, and B will be here like 2, so put 2 over here. Then CA, so CA will go here, and 9, 3, 3 comes because of C. C index is 3, so we come with C, that value 3. Then A is already there, AB is already there, ABA is not. So ABA, we take 10 and put 4 over here because of AB having index 4. And then finally BA, A is already completed, AB is already completed, ABB is already completed. Now we left with this one, ABB, ABBA, this one. A, B, B, A. So we put here 11 index and 6. And finally, we don't have any that symbol or character left. So we put that 1 over here. And finally, because of A is already there, so at the end, here is A. So we put this index 1 over here and make other dash. So the encoded output will be 1, 2, 4, 5, 2, 3, 4, 6. This is the encoded output that we have. Thank you so much for being with us in this session. We saw three techniques: variable length coding, run length encoding, and LZW compression technique. These techniques are very much there with lossless compression techniques and very, very important with different file formats. We saw different numericals, how to implement these concepts, and these are very, very important when we talk about the compression techniques together. Thank you.